Okay, let's have a look at cryptology. So this is where we encode a text message so that it's scrambled up so that nobody else can read it, and then later on we decode it. So there have been movies about this recently. Anyway, what we do is we have to treat all the letters as numbers, okay, because we're going to use matrices, and of course we can't use matrices with letters, so we just assign in order A is 1, B is 2, etc. to these numbers to scramble a message. Okay, so as an example, here is an encryption matrix 5243. Because it's 2 by 2, that means we're going to scramble 2 letters at a time. You could have a 3 by 3 and scramble 3 letters at a time, etc. We'll stick to 2 by 2. It's a little bit easier. And we have to, when we get around to decoding it, we have to use the inverse. But this, we'll explain later, this is not your normal inverse. And because this is not your normal inverse, you have certain numbers are not going to work. You can't just randomly pick numbers. You have to check and make sure that it has an inverse. So for example, if we want to encode, let's encode, let's just say Friday. Okay, so it's 6 letters, so let's see, F is 6, 18, 9, 4, 1, and 25. Okay, so we're going to start with, and we'll encode the F and the R. So 2 letters at a time. Okay, so we take 5, 2, 4, 3. We times it by 6 and the 18 for the F and the R, and this is going to give us 5 times 6 is 30, 2 times 18 is 36, so I'm going to get 66. This next one I'm going to get 4 times 6 is 24, and 54 is 78. Okay, oh, and one thing just coming back up here, I made a little mistake. This Z, we're actually going to make that 0 instead of 26. Alright, because what we're going to do now is we're going to take the 66 and 78 and use these numbers to convert back to letters. But of course, we don't have a 66, we don't have a 78 there. So we have to use what you might remember, which is modulo arithmetic. So we're going to use modulo 26 arithmetic. Alright, so 66 is the same as 26 times 2. Okay, this is 26 times 2, which is 52 plus 14. Alright, 78 is 26 times 3 plus 0. Okay, remember modulo is the remainder after dividing 26. So the remainder after dividing 26. Alright, so the remainder of 66 after dividing 26 is 14. The remainder of 78 after dividing 26 is 0. Okay, so 14 0 now in our table up above is NZ. NZ, New Zealand, great. Alright, so FR encoded is NZ. ID is the next one. ID, we'll encode that, same matrix. Let's see, 9, 4, so we've got 5 times 9 is 45, and 8, so we've got 53. That looks like a 1 after we mod 26. Anyway, 4 times 9 is 36. 36 and 12, we get 48. Alright, and mod 26. 53 is 2 times 26. 26 times 2 plus 1. So the remainder is 1. And this one is 26 times 1 plus 22. Okay, so mod 26, we've got 1 and 22. So this is A and 22 is V. Okay, so we've got NZAV so far. Okay, last two, Friday, 5243, 125. So we're going to get 5 times 1 is 5, and 2 times 25 is 50, so 55. 4 and 75, 79. So we've got 26 times 2 plus 3, we've got 26 times 3 plus 1. Alright, so modulo 26, 3, 1, which is CA. Okay, so Friday, we encode, we get NZAVCA. Alright, so now we've got to look at if we want to now decode using that same matrix. Okay, so the normal inverse of a 2 by 2 matrix is AD minus BC. Now I'm going to write this a little bit differently. Normally I write it 1 over AD minus BC. I'll show you in a minute why I write it this way. Okay, because this is all because of this modulo 26 arithmetic. I cannot have 1 over a number in modulo 26. Okay, I always have to have, I can't have fractions. So to find the inverse of a number, so let's say the inverse of 3. Okay, normally it's 1/3 because an inverse means this is a multiplicative inverse. It's 3 times some number equals 1. Okay, so normally, of course, that number has to be 1/3. But in this case, this is in mod 26. Okay, so in this table here, on the left I've got 3. On the top is the number I'm timesing by, and in order to get a product of 1, I need to multiply it by, instead of 3, I need to multiply it by 9. Because of course 3 times 9 is 27, which equals 1 mod 26. Okay, 27 is 26 plus 1. Alright, so we need to use this this table when we're doing these examples. So how that works with our example we're doing, we've got we're trying to find the inverse of, what is it, 5243. -1. Okay, so we've got 5 times 3 minus 4 times 2 inverse times by, we swap the 3 and the 5 and we make the 2 and the 4 negative. But now remember, we kind of have a -2 mod 26. Okay, -2 is 0, is 2 less than 0. Okay, up here, here's 0. If you go 2 less, you're at 24. Okay, that's the same as 24. And this is the same as 22. So we're going to get some big numbers when we multiply this, which is going to be difficult. But we only have to do it once. We only have to find this inverse once. So we get 5 times 3 is 15 minus 8. We get 7 inverse times 3, 24, 22, 5. We go to a big table here. This is in your book, in your textbooks on page 79. Inverse of 7. Here's 7. We look for the 1. Here's the 1. We go up, and that is 15. Okay, so this equals 15. Okay, you can just check. 7 times 15 is 105. And that should be the same as 1, which it is. Okay, 75 is 26 times 4 plus 1. Okay, there's a remainder 1. They're always, an inverse times a number is always going to be equal to 1. Alright, so that's 15. So let's, okay, so we get 15 times 3, 24, 22, 5. Multiply that out. So multiply it out, we just times everything in that matrix by 15. And now the difficult part is to work out what those are modulo 26, which I've done here. But just as an example, I could put 360 in my calculator, divide it by 26, and I'm going to get 13 point whatever. So 13 is the whole factor, which I put here. 13 times 26 is 338. Okay, so the remainder is whatever's left. 360 is 22 is the 360 minus 338. Alright, so that's how you can do that. And so this gives finally for our decoding matrix 19, 22, 18, and 23. So here is what's going on. We've taken Friday, times it by this matrix to get our scrambled NZAVCA, and to unscramble that we worked out the inverse matrix, which is this 19, 22, 18, 23. So let's just double check at least the NZ here to finish up. Let's see, NZ is 14,0. So we've got this 14,0, times it by our decoding matrix, and we get 266 and 252. This is a fairly easy one. 26 times 10 plus 6. So 6 is the remainder. And this is going to be 26 times 9 plus 18. So we get 6 and 18 the remainders. Does that match up? Let's pray and hope that that matches up with the F and the R that we scrambled. 6 and 18. 6 is F, 18 is R. Okay, so it looks like we're on the right track. So that is some basic cryptology.